I'm April Latham, and I work for the USDA Agricultural Research Service. And back in 2005, we started doing air quality work related to animal production throughout ARS, and we were one of the locations here in Kimberly, Idaho, that was chosen to start doing this type of work. We've been working on approximately 4 different dairies throughout southern Idaho and 2 dairies in California, where we've been trying to look at whole farm emissions and really understand what type of emissions you get in the different source areas on a farm. So looking at the animal housing, looking at manure handling and storage, looking at support animal housing, and long-term storage of manures. And so we tried to do several different types of facilities that were common to southern Idaho and the western US, which is quite a bit different than dairy production in the eastern and midwestern regions of the United States. We tend to have more open lot dairies. We have some freestall dairies, but the support animals are still on open lot dairies. Most of our manure is either handled as a solid and composted, or some is just stacked. Or we also have some dairies that will have a significant amount of their manure stored as a liquid in a lagoon type system. And even on the open lot dairies, there's always manure that comes from the milking parlor that's stored in the lagoons. So we put a lot of time and effort into picking out the dairies that we work on. They have to be fairly well isolated in the landscape in order to feel like I'm getting a really good estimate of emissions from the farm. So we tend to pick dairies that are isolated, or at least don't have a lot of sources of methane or ammonia upwind from them. And I also try and pick dairies that the layout of the dairy itself, where they have the housing and where they have manure storage, tend to be in a way that's perpendicular to the wind, so that I can do a really good job of isolating the different source areas on the dairy to make sure that we're getting really good representative emissions numbers from those different sources. So at the dairies, we focus on measuring ammonia, methane, and nitrous oxide from the different source areas. And the equipment that's behind me is the equipment that we use at the dairies. We have multiple units of these. They are called OpenPath FTIRs. And so what they do is they pass a beam of infrared light from the detector here to a retroreflector that's behind me, which bounces back into the instrument, and it's measuring the concentration of these different chemicals within the path length, which is really nice because it allows us to get a better average concentration from a larger area in the dairy than you would if you were just measuring at a point source. And so then the data that we get with FTIRs, the concentration data, is then matched up with weather data that we get using a 3D sonic anemometer, as well as your basic temperature and wind speed monitors. And we combine those two, and we use modeling to estimate an emission rate from each of the different sources. To get an overall measurement for the farm, is we add the different source areas together to get the total emissions from the whole farm area. There are quite a bit of differences in emissions throughout the year, especially here in southern Idaho. We have very distinct seasons. So your emissions are going to be different in the summertime when it's hot and dry versus in the winter when it's cold and the ground could be covered with snow, or the lots are frozen and the lagoons freeze over. One of the unique features of dairy production in the western US is that a lot of our dairy cows are housed in open lots. And so these are open corrals with dirt floor and then usually a concrete apron. And the manure from the lots are harrowed in the summertime, or some guys sometimes they'll stack it up into smaller piles within the lots. In the wintertime, they tend to scrape the manure and pile it, and they also tend to use straw bedding a lot of times for the cows during the wetter months, which also gets scraped and piled in the lots. So you have a manure source in the lots that is producing ammonia, methane, and nitrous oxide, and then you also have nitrous oxide being produced from the soil within the lots, because they're continually getting manure and urine applied, and nitrogen builds up over time, and then that nitrogen can be denitrified and lost as nitrous oxide. The lots also tend to be the largest source of ammonia emissions on the farm, because the cows are urinating on the lots, and then that Uric acid breaks down pretty quickly to ammonium, and then it's lost as ammonia in a very short period of time. Manure that's deposited on the concrete aprons behind the feed lane is either scraped and piled in the lots sometimes. There are some dairies that might vacuum that and put it into a pit that'll eventually end up in the lagoon. And there are a couple dairies that actually flush those aprons to remove manure from the lots. And then typically what happens at the end of the season, they'll clean out all of these lots, and lots of guys will take it to a compost yard and they will compost it, and then that compost eventually gets land applied. But not every dairy composts. There are some dairies that will just clean it out, stack it as a solid, and then that manure will be land applied in the fall. On a typical open lot dairy, your largest ammonia sources tend to be from the lots, and then your second largest sources can be from the composting area and then the lagoons. When we look at nitrous oxide emissions, the largest emission sources on an open lot dairy tend to come from the feedlot, dry lots themselves, in the composting area, and then we actually do get a little bit of nitrous oxide emissions from the settling basins when they form really thick crusts. When it comes to methane emissions, it can be evenly split sometimes between the enteric methane emissions from the cows themselves and the housing area. And then one of the other biggest sources that we found is these small settling basins where the volatile solids contents tend to be really high, and they generate quite a bit of emissions before the lagoon water then flows into the lagoons, and then the lagoons are another additional source of methane emissions. Although we're not at a freestall dairy, we have done quite a bit of work at freestall dairies in both Idaho and California. And the emissions are a bit different when you're at a freestall dairy. The methane emissions tend to be pretty large from the barns themselves where the cows are housed, but then a secondary, very large emission source tends to be from the settling basins and the lagoons as well. We don't see as much nitrous oxide from freestall dairies, a very minimal amount from the housing area when the manure is moved quickly out of the barns, but again, we do see nitrous oxide emissions from any stored manure that is on the facility if they maybe separate their solids and do some composting, or we definitely see some again from the settling basins when they form really thick crusts. The ammonia emissions from freestall dairies tend to be about evenly split between the housing area and the lagoon system, because what's not lost from the housing area when it's immediately excreted tends to be flushed or moved quickly into the liquid storage system, and then that ammonia just tends to be lost from that section of the dairy instead. Many of the dairies that we work on have their own support animals on the farm, so that's included as part of the whole farm emissions. So for a lot of our dairies out here in the western US, calves are started in hutches, and then they tend to move to group pens and eventually to open lot areas. And the dry cows are actually usually housed in open lot areas as well. So that's a big difference from freestall dairies or dairies where they may not be raising their own replacement heifers on site, and these emissions are also included into our overall calculations. We have two slides that kind of show some of the results from the emissions work, and this is focused on just the greenhouse gas emissions. If someone's interested in the ammonia emissions, we can provide information on that as well. I just gave 4 examples of 4 different dairies that we've worked on. This first one here at the top is a small open lot dairy, and I've tried to break this out by where on the dairy you see these different emissions. For methane, you can see that the majority of methane is coming from the lots, and that would be enteric methane. From the cattle, a little bit from the calf pens, which is probably from the bedded pack mostly, and a little bit from enteric, but not very much enteric at that part in their life. A little bit from the lagoon, and this other big chunk comes from the settling basins. And again, that's because when they form a crust, you can end up getting denitrification of nitrogen in those crusts, which then gets volatilized, and then a little bit lost from the compost. And we also get nitrous oxide from the lots, as I mentioned, from the soils in the lots, and then when you compost the manure, or anytime you have stacked manure on the farm, that can lose nitrous oxide. And I also wanted to show this on a global warming potential, because it's really easy to in some cases dismiss this nitrous oxide because the bars end up looking really small from your different source areas. But you have to keep in mind that the global warming potential of nitrous oxide is close to 300 and methane is only about 28. So when you multiply those out and look at the total global warming potential, you can see that on an open lot dairy in particular, you can have a really large piece of your overall global warming potential coming from nitrous oxide on the farm. In this particular farm, the GWP was about 3.5 pounds per gallon of milk. You can see how these different source areas are contributing to both the methane and nitrous oxide carbon footprint on the farm. This farm below it was another farm in Idaho. It was a freestall, but the cows actually had access to the lots as well. And this farm had an anaerobic digester. And you can see that the methane was pretty much evenly split between the enteric methane in the barns and the lagoon system. There was some nitrous oxide from the lots in particular, and then a little bit from the lagoons. And when you multiply this all out, you can see the global warming potential contribution from these different source areas. And this one was a little bit higher overall GWP per gallon of milk. But I should also point out that this particular dairy had some areas where they had support stock and dry cows on lots, which were not included in this calculation. We did not include methane leaking from the digester, and there were a few other areas that probably are producing methane and nitrous oxide that we were not able to measure on the farm. This value is probably, in all reality, higher than 6 pounds per gallon of milk. And these two dairies were actually dairies that we worked on in California. One was an open lot dairy, but they used a flush system, and they also had some animals in a barn. So when we say barn here, that's really the barns and the open lots. It's just the housing area. The majority on both of these dairies of the manure is handled as a liquid. And you can see when you handle manure as a liquid, you really see these large amounts of methane emissions coming from that section of the farm. And in both cases, it was greater than the enteric methane produced by the cows. And you still did get a little bit of nitrous oxide from the barn area, the lagoon, and the settling basin. And again, I mean, when you're doing this research, there's not a lot of research looking at nitrous oxide from production facilities, and it looks really small, but when you multiply it out to the global warming potential, you can see that this can contribute a pretty large chunk of your whole GWP per gallon of milk. So here they are again, the methane and nitrous done on a global warming potential. This dairy was about 14.5 pounds GWP per gallon of milk. And the freestall dairy, very similar. Again, that's because both dairies were storing most of their manure as a liquid. You see these really large losses, particularly from the settling basins where they have a high concentration of volatile solids, a little bit of nitrous oxide from each of the sources. And again, this dairy was slightly higher, but only 14.5 versus 14.5 pounds CO2 equivalents per gallon of milk.
Could you please explain the difference between a lagoon and a settling basin?
What we're calling a settling basin is most of our liquid handling systems are set up that the fresh manure will flow into what we call a settling basin. And they tend to be long, skinny cells. They're usually quite a bit smaller than the lagoon. And the purpose of those is to capture as many solids as possible, and that the water going from the settling basin into the lagoon has a much lower solids content. It makes it easier to clean out the solid manure over time when it's more concentrated in a smaller cell than having it in your main lagoon, which is where you're going to irrigate, that liquid and send it through your pivot. So it's really used to capture solids.
What is the source of methane from the lots?
From the lots, it would be enteric methane from the cows. In the springtime, though, we have noticed when there's a lot of really large piles of manure, especially with straw, and things are warming up in the spring, those piles will really start to cook, and you can get an extra amount of methane coming from that manure storage inside the lots in addition to the enteric methane.
What new practices can be done to reduce emissions from the dairy lots, piles of manure, and lagoons to help strive for a net zero emission dairy farm?
That's something where we need a lot of research. Most of our research up until now has just focused on getting baseline emissions data from actual working dairies and really getting a good understanding of where emissions are coming from, figuring out how we're going to mitigate particularly nitrous oxide emissions is a challenge that we're going to need a lot of future research on. There has been research related to enteric methane emissions and how we can reduce that. If you look at manure, the methane emissions from manure storage If you separate your solids, any solids that you can keep out of the liquid system will decrease your overall methane emissions from the manure storage part of your facility. And those are the things we know right now that work really well. I think everything else is going to be developing new technologies to capture more of those solids, maybe capture more of that nitrogen so that we can reduce the overall emissions of both methane and nitrous oxide. But that's an area that we need to start working on next.
How large of a reduction of methane emissions from settling basins do you expect with previous solid separation?
We don't have on-farm data on that, and it becomes difficult to kind of get on-farm data because no two farms are the same, so it's really hard to compare one farm versus another. The two farms that we looked at in California, they both used a flushing system, although one was open lot, but when we looked at the open lot had a screen separator, so it was separating out some of the volatile solids. And when we looked at the amount of emissions on a per head basis, it did look like there was maybe a 20 to 30% bona fide reduction in methane emissions from the liquid storage when they were using the solid separator. But there's been very, very little data collected on farm that's really evaluated these mitigation practices to see what the true on farm potential of these different practices are.